So students, we have a question here. This is our question that in a circle, we have AB as a diameter. Okay, we have AB as a diameter, and CD is the chord equal to the radius of the circle. So basically, we have a diameter, which is as we know that the maximum and the largest chord of the circle is our diameter, and CD is also a chord in that particular circle. So we have a AC and BD when extended to a point where it will meet at beyond the circle. It will be the point is E. So it will be the point E. So we have to prove that AEB will be the 60-degree angle. So basically, for basic understanding and basic concept of this question, we have to draw our circle and other particular things so that we can understand it easily. So starting with the circle. So we are making a circle here. Uh, this is the circle. Put it down so that we can easily understand this is our circle, and make it more thicker so that we can easily understand it. So here we have a circle. Now we just have to mention the diameter first. Okay, the diameter will be the maximum chord, is the largest chord of the circle. Okay, this one our this is the chord. This is the chord of the circle. We can increase the thickness also so that we can easily understand it. Okay, now this is A. A will be here, and another one is B, which is here. Okay, so we have a diameter that is A and B, and now point it here so that we can understand that this is the point O, that is the center of the circle. Okay, so basically we have a center at the center O. Now, this is the question we have, but it is half of the question. So we starts with the chord. So starting with the chord will be somewhere here, somewhere here. Okay, this will be the chord. We can increase the thickness and also the blue color. So both of the chords and the maximum chord, that is diameter, which is A and B, and sorry, and another that is C. Okay, and D. This will be the chord. Okay, now we have understand it that we have to understand it that we have a AB and we have a CD, but there is a twist that AB, AC and BD, that is the diagonal of the both the sectors. So we have to join that first. Okay, so we have to join AC and BD so that we can further increase it to the point E. So starting with the line from A to C, somewhat somewhere here. Okay, I can increase the size of the line, and now from BD it will be somewhere here. Okay, we also increase its density. This will be a question. Okay, here we have a question. Okay, now we can mention the point E here. Okay, so so this is our question, but we have to prove that AEB is 60 degree. So this will we have to prove that this is the 60-degree angle. Okay, this will be 60-degree angle. We have to prove. So uh, starting with the given, starting with the given, what we have basically we have uh, AB equals to diameter CD equals to chord. Yeah, and uh, there is something which is very important in this question that we have to construct something. Okay, we have to construct so that we can easily solve this question. Okay, so to prove, to prove what we have to prove here. Now to prove, basically we have to prove here that this angle AEB is 60 degrees. Okay, this we have to prove here. Now it is clear that we have to prove that AEB, that is A, E, and B, that is 60 degrees. So first of all, we have to do some constructions. Constructions. What we have to do? Make a single color so that we can easily understand what we have and what we don't have. So join. First of all, we have to join this C O C O O D, also C B C B, and mm, we have OD, we have CO, and we have CB. Okay, so first of all, we have to join this. So take a line so that we can easily make a line here. This will be the okay. Now from this we can increase the thickness, and lastly we have from here to here also. Okay, now we have joined OD, we have joined OC and CB as well. So starting with the solution, that is proof. Proof for this. So we starts with the proof. Okay. Now we have a basic theory of this whole question. Now starts with the what we have to approach. First, we have to approach that uh, with the construction, we have OC and OD as the radius. Okay, we have radius here. This one both are radius. So both are the radii. Okay, both are the radii of the circle with center at O. Okay, done. So OC equals to OD equals to CD. As we have that this chord, this CD chord is equals to the radius. So this is given. Okay. Now, as we have OC equals to OD equals to CD. That's why, therefore, therefore, this triangle, triangle COD will be equilateral triangle. Equilateral triangle. Yeah. Now, this one is the equilateral triangle. An equilateral triangle because in equilateral triangle we have three sides. All are equal to each other. Okay. As we know that this is the equilateral triangle. So basically, when as we know that when the when the triangle is equilateral, the angles, all the angles are 60 degree. Okay, all the angles are 60 degree. How? You have a question here that how all the angles are 60 degrees. So by the angle sum property, by the angle sum property, by angle sum property, angle COD plus angle angle CDO plus angle DCO equals to 180 degree. Okay, by angle sum property. By angle sum property. Okay, so all these three angles are equal because it is a equilateral triangle. So 3 into angle COD equals to 180 degree. Now angle COD COD equals to 180 degree divided by 3. That will be 60 degree. So we have this one will be 60-degree angle. Okay. Now, as we know that this is the 60-degree angle. So uh, after that, we have we have CD as the arc, and at CD segment, at CD segment, angle COD equals to 60 degree. So your angle CBD will be 30 degree. Sorry, 30 degree because of because of the angle subtended subtended at the center of the circle at the center of the circle at the center of the circle is double double the angle subtended subtended by it at any point on the remaining part of the circle. Okay, here it is clear. We have to shift over it so that we can easily write and you can easily understand. Okay. So basically, what we have that this is the CD. This is CD, and this is the segment of a circle. When what we have a theorem that COD, it is at the center of the circle, which makes 60-degree angle on that particular segment, that is CD. Over there, we have a another angle that is CBD. This will be the 30-degree angle. Okay, this will be the half of the center angle. Okay, here it is clear that we have CBD. CBD is 60 degree. This will be the angle. Okay, now starting with this. Huh. So we have CBD equals to 30 degree. We have COD equals to 60 degree. Now angle ACB equals to 90 degree because angle at the semicircle. Okay, then angle at the semicircle will be 90 degree. That is this one. This particular angle is 90-degree angle. Okay, this particular angle. Okay, so we have to mark it here that this will be 90-degree angle. Okay, this will be the 90-degree angle. Sorry, this will be the 90-degree angle. So angle angle ACB equals to 90 degree. Angle at the angle at the semi circle. Angle at the same circle. Okay. Now, uh, now ACE will be will be the straight line. Then Then angle ACB plus angle ECB equals to 180 degree by angles and property. Sorry, by linear pair. By linear pair. As we know that we have a straight line, there is a angle between two uh, bisectors is 180 degree. Okay, so by linear pair, it will be 180 degree. So first angle, that is angle ACB, is 90 degree plus angle ECD equals to 180 degree. Okay, then angle ECD will be 180 degree minus 90 degree. So this will be 90 degree. Okay, now here it is clear that this will be also 90 degree. Okay, this will be 90 degree, this will be 30 degree, and this will we have to find out. So consider the triangle. So consider the triangle. Consider the triangle ECB. Okay, now consider the triangle ECB. Put it here so that we can understand it easily. Triangle ECB, which is this one, this EC, and that will be B. Okay, so it is clear that we have ECB is angle ECB is 90 degree, EBC is 30 degree, and CEB, which we have to calculate here. So angle, so uh, do it in a different color so that we can easily understand it. Okay, angle ECB plus angle CBE plus angle CEB. Okay, now this will be 180 degree. How? By angles of property, by angle um, angles of property. That is clear. Okay, now angle ECB, that is 90 degree, plus angle CBE, that is 30 degree, plus angle CEB, that will be 180 degrees. Now angle CEB, that will be equals to 180 degree minus 120 degree. That will be 90 plus 30, that is 180 degree. Sorry, 120 equals to 60 degree. Hence, it is clear that we have a that will be equals to angle AEC. Okay, here we have proved. Here we have proved that this will be the angle. Okay, guys, we have proved that this will be the angle. Okay, this will be the 60 degree angle. Sorry, this one.